Hello and welcome. In the last videos, I've been doing multiple math animations and I'm continuing with that. So here I have kind of setup for a neural network illustrating the very classical case of recognizing a hand-drawn digit. Just to give a summary for those of you that aren't familiar with neural networks, I have a kind of set of images where each image is 28 by 28 pixels in a grayscale value from 0 black to 1 white and continuous between them. And one of the images is the one that you see here, number 3, as we can recognize. The inputs from that, like each pixel, is going to a first layer, which has multiple neurons. And each neuron is kind of summing the inputs, creates a signal, a value, which is then used in the next layer as a kind of the signal. And so this is done between the layers, and it reaches a final output layer where we can see what digit the network thinks it is seeing. So it's a pretty easy mapping from 0 to 9. So if this neuron lights up in the end, the network thinks it's a 0 and thinks it's a 1, thinks it's a 2, etc. This won't be like either black or white completely. They will be like on a grayscale, so illustrating probabilities. Yeah, I think this setup is quite nice. It's very detailed. The animation library that I have made, Define Motion, kind of enables a lot of complexity. You can see when I move around here that it is quite heavy to run. But if I play this, you can see that the animation as it is like a blue wave going forward, and you can see neurons firing up and producing the kind of result that I mentioned with a grayscale value for each of the neurons in the output layer. And this guess is completely wrong, which is expected. So the correct answer is 3, but the strongest neuron is like a 9. So, and most of them are like gray, so completely uncertain result. But I will let this run back and forth for a while so you can see how it kind of converges to a good network that is trained that actually produces a certain answer that is correct. Before I do that, though, I would like to show you kind of how the back propagation is visualized. So if I play this again, I haven't enabled hot reload, so it's kind of need to begin from the beginning all the time. But if I pause here and zoom in, so I have the blue wave going forward, and then it's initially a red wave going back, and the red wave is illustrating the back propagation, where if the weights, which the connections between neurons are very wrong, which they are likely to be in the beginning, they will be red. But if they are kind of right, they will be green. So the weights are randomly set to begin with, so we can expect them to be kind of wrong. It will be very unlikely for them to be correct. So we should expect a very red wave in the beginning, but then when the network learns, it will become more green. So I can play this and you can see it like a time lapse where you see the color change. Then we can look at the result. All right, so now it has kind of trained or learned, and you probably saw the red wave become kind of orange and then green, and the answer is now much more like certain and decisive, and probably correct as well. If assume it, yeah, so it's a 7. It looks like a 7, and it concluded as 7. So one thing that you may have noticed when you looked at this is that it learned much quicker than it would be if it actually were using the backpropagation itself. So how this works is that I have created an identical network in Python, trained the weights, saved the weights to a file, then in this imported those weights, and I begin with starting weights and then converge into the final weights. So I'm not doing the backpropagation here because it would require way too many cycles back and forth, which would be like unpractical for an animation. But it's still doing the forward propagation correctly, so it's not like faking the value it actually gets. It's using the weights, and it can also like show correctly how wrong the weights are in the like red wave that goes back, the back propagation, because it knows how the weights should be, like it kind of would if it would have done a gradient descent, as it's called, because then it would like see where the derivatives should be and which one are the most wrong. But yeah, so that is why it could learn so fast. And yeah, I just wanted to show you like what I was kind of working on. And so hopefully it was interesting to see. And that was everything for me. So bye.